Well, hello, my friends. Welcome. Today I want to talk about one of the bigger ideas in all of algebra, and that would be the quadratic formula. So get yourself something to write with because we're going to be doing some thinking, and thinking means connecting things. So let's have a good record of the things that we connect. So let's go ahead and get started. All right, so ways of solving quadratic equations. One of the first ways was to factor. And that would be if we had something like, I don't know, x squared plus 7x plus 12 is equal to 0. We can look for the ways to factor that. We can factor that down into an x plus a 3 times an x plus a 4 equals 0. And then we can use the zero product theorem, which says whenever two or more factors are multiplied and the product is 0, one or more of the factors must be equal to 0. We could do just the simple, I don't want to do that. We could do simple like square root property, or what I would call extracting the root. That's if you have something like, I don't know, x minus 3 squared is equal to 9. You take the square root of both sides and then you do your answer from there. We could even do then completing the square, which would be to take something in the form of ax squared plus bx plus c equal to 0, and then we could rewrite it like that by completing the square, making it a perfect square trinomial. And that would work. So now let's add to it the fourth way, which is the quadratic formula. The quadratic formula says if ax squared plus bx plus c equals 0, then when you solve it, you get x is equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. Where are those a, b's, and c's coming from? This b, and this b, and this a and c, and this a over here, those come from when you have it written in standard form. So you really can't do the quadratic formula until you get it written in this descending exponent form with then 0 over here on the right hand side. And notice that a couple of other of those actually worked that way too. Completing the square had you like set it equal to this, and then factoring also had it set it equal to that. But where does the quadratic formula come from? Is it just divinely given to us, right? Was it like printed on the back of the 10 commandments that God gave to Moses on Mount Sinai? It's like, oh, here's the 10, and then on the back, oh, look at this, it's something special, the quadratic formula. God tells us some things directly, but the quadratic formula is not one of those things. Where does the quadratic formula come from? The quadratic formula actually comes from completing the square, doing this method that we did in a previous video, when you don't know what a and b and c are. You say, what do you mean? Well, if I completed the square by taking the c and moving it across and factoring the a out of those, I would get a times x squared plus b over a x, leave space, close it, is equal to negative c, and then dooba 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 dooba, you complete the square when you don't know what the numbers are, because that's algebra. Algebra is the mathematics of unknown numbers. You eventually wind up with then taking the square root of both sides like this, and then you wind up with that right there. And that's actually a pretty neat process. I remember one time I was teaching in a classroom and we were doing this, and I didn't frame it as we're doing the quadratic formula. I was just like, hey, what if we tried to complete the square and we didn't know what the values were? Like, I don't know, let's try that. And so I kind of went, it gets complicated, but I was going on the board and the kids were kind of like, oh my goodness, Mr. Marsh is having great fun entertaining himself. And then I got like one or two steps before this, and a student named Charlie like saw it on the board and he started to get all excited. He was like, wait, what is that? Like, I know that. I've seen that before. And finally I got all the way and he was like, oh my gosh, that's the quadratic formula. And I was like, aha, you got it. He's like, wait a minute, you did that on purpose? I was like, yeah, where do you think it comes from? So the quadratic formula. Actually, they're like, you need to memorize this. This needs to be part of your, whoops, probably can't see it because my face is in the way. There we go. How's about that? I just now realized I got this little corner that's hidden by my face. The quadratic formula is one of those things that really you need to keep track of. In fact, actually, when I was graduating college, like 2 weeks before I was finished with all of college, the dean of students for the whole college came in and said, we'd like to take a survey just to see what you remember from all of your different courses here at the university. And it was just a general, like a 20 question thing that they knew no matter what your degree, they knew that you had done some basic things in all areas. That's what a university is. It's a unifying kind of a thing. And the only math question on there was, what's the quadratic formula? So the university thought that everybody, when they graduate, what's the one thing that they expected maybe that you should remember? What's the most important thing was, well, the quadratic formula. So you need to memorize that. And you know, it's funny how things work. The mind actually memorizes things better when it's put to song. So there's a song for that. It's actually a song that uses the melody to row, row, row your boat. You know that song? Row, row, row your boat gently down the stream. Merrily, 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 life is but a dream. But now we can say x equals negative b plus or minus root b squared minus 4ac all over 2a. So how was that? You want to sing it along with me? Good. But let's get some musical accompaniment. Hold on. I've got my guitar. Let's see if I can pick it out. X equals negative b plus or minus root b squared minus 4ac all over 2a. Do it again. X equals negative b plus or minus root b squared minus 4ac all over 2a. Anyway, you should memorize that at some level. And notice that I started the formula with x equals negative b plus or minus root. You need to include the x equals on there. So anyway, here we go. Solve, example number 1. Solve by using the quadratic formula. Okay, here's what I'm going to do. Every time I use the formula, and you too, every time I use the formula, write the formula down. Sing the song if you have to. X equals negative b plus or minus root b squared minus 4ac all over 2a. But wait a minute. It's not in standard form first. So I'm going to have to rewrite it in standard form. What does it mean, standard form? I want the right-hand side to equal 0, or the left, but usually it's the right-hand side. So I'm going to have to subtract 11 from both sides. What I get is this. I get x squared minus 10x minus 11 equals 0. Good. Now let me identify my a and my b and my c. A is equal to 1. B is equal to negative 10. C is equal to negative 11. And you've got to do it in that order. You cannot just come through and pick the first, second, and third things that you see. Some students will not be paying very close attention, and they will say, oh, A is 1, B is negative 10, and C is 11, because it's just 1, 2, and 3. But no, wait a minute. You've got to set the right-hand side equal to 0. C is negative 11. And if these things were written out of order, you would have to put it in standard form first. So you have to put it in standard form first. And notice that the A and the B and the C do not include the X. When you substitute those in here into the quadratic formula, you do not substitute x into it. It's just the coefficient. Okay? So now let me do substitution. And I'm going to then use these values. X is equal to negative of b. What's b? Negative 10. Notice I'm using parentheses to substitute. Okay, it's negative of negative 10. Don't simplify yet. Substitute in first. Then simplify as a second step. Plus and minus the square root of b squared, negative 10 quantity squared. Notice the negative is in the parentheses as part of the base. Minus 4 times 1 times negative 11 all over 2 times a, which is 1. Okay? You need to do this step without any simplification. Because when you make a mistake, notice I didn't say if, when you make a mistake, we need to go back through and be able to find out where you made the mistake. Did you make the mistake in the formula? Maybe you did. If you don't have a record of the formula down there, we can't fix it. And you don't know why you got the problem wrong. See what I'm saying? Did you make the mistake in substituting things wrong, either with like fumbling a negative or you got the things out of order or something like that? If you made the mistake with substitution, you need to be able to see that as a separate step. Or did you make the mistake in simplifying? Well, okay, then we need to see each one of these steps here, because when there's a mistake, we have to track down where it is and fix it. Don't just erase the problem and start over again. Find your mistake and fix it, because when you do that, you are fixing the path in your mind. And that's what you really want. You want the path in your mind fixed. Okay, so let me finish now. So this is going to be then x is equal to a negative times a negative is a positive, so that's 10, plus or minus the square root of negative 10 squared. That's 100. But then notice this. All of these are multiplied together. Negative 4 times positive 1 times negative 11. So what's a negative times a negative? Plus. And that's one of the most often mistakes there, is not multiplying a negative times a negative. This case, it's going to be a negative times a negative, it's plus. Now, 4 times 1 times 11, that's going to be 44, all over a 2. And now I keep going. You don't have to do it all in one step. Just keep doing, go small steps. So then x, come on x is equal to 10 plus or minus the square root of, what's 100 plus 144? That would, I gave the answer away. What's 100 plus 44? 144. That's so gross. I'll come back to that in a second. All divided by 2. Every time I see the number 144, I always stop for a moment and say, that's gross. Because it is. 144 by definition is a dozen. It's 12 times 12, and that by definition mathematically is gross. Now, it doesn't mean gross like normal speech, which would mean like disgusting. Gross used to mean like overly large, like bigger than big, like a dozen, which is 144. And only later on did the word gross come to mean disgusting, like so big that it's disgusting or something like that. And now it's not related to the number at all. But I just want to remind you, 144 is a gross of things. Maybe you've heard the little rhyme, a dozen, a gross, and a score, that much and no more. A dozen is 12. A gross is 144, and a score is 20. You probably knew that from Abraham Lincoln's Gettysburg Address, right? It's 4 score and whatever it was, 4 score and 7 years ago. A score is 20, so 4 score would be 80. Anyway, we're going to keep on going now. So x is equal to, oops, I'm almost out of room. So x is equal to, x is equal to 10 plus and minus, what's the square root of 144? 12 over 2. And now I'm out of room, so I'm going to keep going here. What I do is I've got 10 plus 12 over 2, and I've got 10 minus 12 over 2. Now be careful when you simplify. You cannot simplify in pieces when things are added or subtracted. You cannot simplify this and call this a 1 and call this a 6 and say it's 10 plus 6, which is 16. That's illegal canceling. Don't do it. This whole thing is a group. Okay, you've got to simplify the group first. Undo. There we go. So this is a group. What's 10 plus 12? 22 over 2. And what's 10 minus 12? Negative 2 over 2. And so our final answers then are 11 and then negative 1. Okay. Now, just for entertainment purposes, was this thing solvable by another method? If I come back up here and look at this, does that factor? What are my factors of 11 that when I subtract them give me 10? Oh, that factors into an x minus 11 times x plus 1 equals 0. And so if I solve it by factoring, I would get x minus 11 is equal to 0, so x is equal to 11. And x plus 1 is equal to 0, and so x is equal to negative 1. Okay, so yeah, I've checked it in a sense there. But oftentimes things won't always factor to be integers. Some polynomials are prime, some trinomials are prime. You cannot factor them. But the quadratic formula always works. You can always solve a quadratic with the quadratic formula. You can't always factor it. Okay, so now example number 2. Let's work this one. This one's a little bit different. Solve this one by using the quadratic formula. Okay, so is it in standard form first? Yes, it's in ax squared plus bx plus c equals 0 form. Okay, so then what's a? That would be 1. What's b? 8, positive 8. What's c? 16. Okay, so good. I've identified my a and my b and my c. Do the quadratic formula. X equals negative b plus minus root b squared minus 4ac all over 2a. And now substitute. X is equal to negative 8 plus and minus the square root of 8 squared minus 4 times 1 times 16 all over 2 times 1. Okay, so keep going. X is equal to negative 8 plus and minus 8 squared 64 minus 4 times 16, because it's where'd my calculator go? Oh, there it is. Oh, I should know that. 4 times 16. I have a feeling. Oh yeah, look at that. It's 64. Okay, all over 2. This one's turning out kind of nice. X is equal to negative 8 plus or minus the square root of 0 all over 2. Well, what's the square root of 0? 0. So this is negative 8 plus or minus 0 all over 2. But isn't plus or minus 0 ineffective? So this one now is just equal to negative 4. Only one solution. How many did we have right here? Well, we had 2 different ones. Why is that? Because that number was a number greater than 0. The thing that's under the square root is important because that's what you're adding or subtracting. Here we were adding and subtracting a non-zero number, so we had 2 answers. Here we're adding and subtracting 0, so we just get 1. Actually, if you want to use an alternate method, this thing right here factors into x plus 4, quantity squared, is equal to 0. And so if you remember from extracting the root, if I square root the left and square root the right, I get x plus 4 is just equal to 0, and there you go. You get your answer of negative 4. Okay, so that was a good one. How about this one? Oh, look at this. See, this one's nice. We now have a number of a other than 1. Let's see what we got. Is it in standard form? Yes, it is. Okay, so a is equal to 2, b is equal to 6, c is equal to negative 7. Quadratic formula. X equals negative b plus and minus root b squared minus 4ac all over 2a. Substitute in. X is equal to negative 6 plus and minus the square root of b squared. So 6 squared minus 4 times 2 times negative 7 all over 2 times a, which is 2. Okay, now let me simplify. X is equal to negative 6 plus or minus the square root of 36, and again, watch here, a negative times a negative. Positive, 4 times 2 is 8 times 7. I never was good with that. 8 times 7, 54. Dang it, 56. I've had trouble with that since 3rd grade. But I'm going to master it, I promise. All over 4. Okay, keep going. X is equal to negative 6 plus or minus the square root of 36 plus 56. That would be 80 plus 12. 92. All over 4. 92 doesn't strike me as being a perfect square. But can we reduce it? Is 92 evenly divisible by a perfect square? So let's do 92 divided by 4. Does that work? 23. Ah, there we go. So I can reduce this now and say that it's x equals negative 6 plus and minus 4 times 23. The 4 comes out as a 2. 2 square root of 23 all over 4. Almost done. I bet you want to do something here with this 2 and this 4 and cancel that and call that a 1 and call that a 2. You can, but not like I just did. Why is that? This is division. Does division cancel plus and minus? Is division the opposite of add or subtract? No. What's division the opposite of? Multiplication. You can only cancel things multiplied by division. So I can't cancel in here in pieces of things that are added or subtracted. What I really need to do is I need to factor something out of the top. So I'm going to go sideways here. What can I factor out of the top? I can factor a 2 out. What's left? Negative 3 plus and minus 1 times the square root of 23. Do you see how I factored a 2 out of the top piece? I've got 2 things here. I've got a piece here and a piece here, and both of them share a 2. I factored that out. Okay. Now all divided by 4. Now you can cancel that 2 and that 4. It's everything divided by 4. This cancels and that cancels, leaving me a 1 here and a 2 here. And so my final answer then is equal to negative 3 plus or minus the square root of 23, all divided by 2. There we go. Now I got 2 answers there, right? It's going to be negative 3 plus root 23 over 2, and it's going to be negative 3 minus root 23 all over 2. And you can get decimal approximations if you wanted to by typing that in here and so forth. But these are exact values, okay? Now, how many answers did we get here? Well, we got 2 of them again. Why is that? That is because we are taking the square root of a number that's bigger than 0. But this time it's not a perfect square. So I get 2 answers, but they're not integers. Okay, now example number 4. All right, solve this one using the quadratic formula. Not in standard form. You can't come through here and say that A is 1, B is negative 6, and C is negative 10. C is not negative 10. You've got to get it set equal to 0 first. So x squared minus 6x, pass the negative 10 over by adding, plus 10 is equal to 0. Okay, there we go. Now, A is equal to 1, B is equal to negative 6, C is equal to positive 10. Quadratic formula, x is equal to negative b plus minus root b squared minus 4ac all over 2a. And then substitute x is equal to negative of negative 6 plus and minus the square root of negative 6 quantity squared minus 4 times 1 times 10. Almost had enough. All over 2 times 1. This is going to get good. X equals 6 plus or minus the square root of, what's negative 6 squared? 36. And now watch. A negative times a positive is a negative. 4 times 1 times 10. 40. All over 2. If you see the potential problem there, you're sharp. That's good. x is equal to 6 plus or minus the square root of what? -4 all over 2. Oh no, I have to use my imagination because I'm taking the square root of a negative. What does that give me? X is equal to 6 plus or minus what? What's the square root of a negative? I, right? Imaginary number. What's the square root of 4? 2. All over 2. Looky there. Oh, something's going to cancel. Factor a 2 out of the top. 3 plus or minus I all over 2. And this cancels. Oh, nice. See, look how this comes down now. I'll raise it up here. Your final answer here is just 3 plus or minus I. There we go. Okay. Make sure you just don't do illegal canceling. Some students are going to go like, oh, these cancel, so it's 6 plus or minus I. No, it's not. You got to divide the 6 by 2 as well. 3. Okay. So these are two imaginary solutions. Why do we get 2 imaginary solutions? Because you're taking the square root of a negative. So the thing that's inside the square root is very, very important. It tells you the type and the number of solutions that you've got. And so that's what I want to talk about next. The discriminant is this thing in here in red. The discriminant is this thing right here, the thing that's inside the radical. The discriminant is b squared minus 4ac. Okay. Now, why is it called the discriminant? Discriminant, the root word is discriminate, which most people nowadays think discrimination is bad. Some of it is, but some of it's not. And so let's talk for a second about that. Discrimination basically just means you're making a value judgment of one thing over something else. Now, the value judgment could be good or bad, right or wrong, true or false, that kind of a thing. When the police officer sees me drive through a school zone at 50 miles per hour and you drive through the school zone at 20 miles an hour, the police officer will rightly discriminate against my speed. Because in the school zone, the speed limit's 20 miles per hour. He's making a choice. This is the right thing and this is the wrong thing. Okay. When I grade your math papers, I am discriminating against your answers. Are your answers correct or are your answers not correct? That's a form of discrimination, making a value judgment. Now, where people get into trouble with it is we make value judgments on people based upon things that don't really matter. Things like national origin or race or other things like that. To say that some people are good and some people are bad because of their ethnicity is wrong. And that's a form of discrimination. For me to say that's wrong, yeah, that's discriminating. If you say it's wrong to treat people one way versus another way, or to think one group of people are good and another group of people are bad because of their ethnicity, no, that's wrong. And you're discriminating when you do that. You're saying there's right behavior and there's wrong behavior. So there are things that we are right to judge, true or false, right or wrong, good or bad. Behavior and ideas are included in that. And so what the discriminant does here on this, it allows you to make a choice, to make a value decision somewhat over what kind of answers you have. So if the discriminant, if the value, and the discriminant in math is a number, okay? It's a number in the end. If the discriminant is, I'm going to use, let's say like, I'll use capital D for the discriminant. If the discriminant is greater than 0, you have 2 real solutions. And we saw that earlier. Where was one where we had a positive value underneath the radical symbol? Here we go. When we did this one, and our discriminant was 144. That's bigger than 0. Okay. How many solutions did we have? We had 2 solutions. Now, if the discriminant is a perfect square, you have 2 integer values. If the discriminant is positive but not a perfect square like we did right here with 92, then you still have two real numbers, but they're not integers. They're irrational numbers. Okay? So, what's another option? We also had the option where the discriminant was equal to 0. And so we had one unique real solution. If your b squared minus 4ac is equal to 0, you have one unique answer. Where did we have that one? We had that right here. Okay. The value under the square root, 64 minus 64 is 0. How many answers did we have? We had one unique answer. Now you could say it's a double answer. You got -4 twice because you added 0 and then you subtracted 0. Okay, but it's still one unique answer. All right, and then what happened? I don't know what happened. And then there's the next one when you have the discriminant less than 0. Then you have two imaginary, oops, that's an M. Two imaginary solutions. And that was what we had here at the end. Our discriminant, our value under the radical sign was negative, and so we had two imaginary solutions, okay? Now, I don't have a place in the notes for this, but this is what it looks like then when you graph these things, right? We've talked about graphs before. What does this mean? Remember that this is where all of this is where y equals 0, right? Because aren't we doing this where the y value right here, this would be the y value right here, and we're saying where y is 0, okay? Here's what this would look like. If our solution is 11 and -1, what that means is we're going to have some parabola here where it crosses at -1 and it crosses at 11. Remember, these are zeros of the function. Okay, we did them analytically rather than just looking at the graph, but we found them. That's where it crosses the x-axis. Where does this one cross the x-axis? Well, it only touches once. Where does it touch? It would be a graph that looks like this. It touches at -4, and it comes down and only touches, it does not cross, and then it goes up. Okay, that would be a graph that looks like that has one solution. Okay, how about this one? You've got two solutions again, but they're not going to be whole values. Again, you would still get something, I don't know what those are as decimals. You can maybe run those as decimals if you wanted to know. But again, you're going to get something that looks, like this. Here's one of the solutions and here's the other one. Whatever these two things are. Maybe this one is the negative right there, and then this one is the positive one right there. It's really kind of, sorry about that. But what about this one? What does the graph look like when you have imaginary solutions? Quite simple. It doesn't touch the x-axis. It looks something like that. Okay. No real solutions. They're imaginary. Whew. Man, that's a lot of work. But it's good, right? One of the things that you get from this, even if you're never going to use this in your job, is it teaches you to be very, very precise about things. And when you make a mistake, to go back through and find out, well, did I make a mistake in the principle of the formula, right? Did I make a mistake in putting the things in that I say are equal to those things? Or did I make a mistake in the analysis or something like that? And that's useful. We need to do more thought with other things, not just mathematics. And so maybe there's a universal principle that we can apply. And it's like, well, okay, what's the universal idea? That would be like the formula. Do we have the universal principle right? Did we understand the details of the situation that apply to the universal principle? And then did we analyze it properly? No, it's good stuff. So, since I'm singing songs today, here's how I will end. May your days be merry and bright, and may all your mathematics be right. Have a good day. Bye-bye.